กดอัดเรียบร้อยก็นะครับโอเค we will continue from last time นะครับ last time I told you how to find the indefinite integral from sorry of fx dx and it's equal to something when you take the derivative it's equal to small fx here and then when you have big fx you add c to it okay then you get a solution of the integral okay and I did talk about some properties right let me pull up the property which are this okay the integral of a constant dx is equal to kx plus c because kx when you take derivative you get k okay and then you add c to it and the integral of x to the power n okay and the solution that you might guess is x to the power of n plus 1 okay the degree has to be more than the left side by 1 and after you check the solution when you take derivative you have extra n plus 1 up front and you don't have it here right so you want to eliminate this n plus 1 so you adjust your guess solution by divide by n plus 1 so after you take derivative the n plus 1 will be cancelled okay so that is the solution and the integral of a constant time function the constant can come out okay and when you have the integral of two functions add or subtract together the integral can distribute inside for each function okay so let me give you an example of this problem actually the first three okay so example is find the integral of x squared plus 4x minus 5 dx okay well I'm going to apply uh, the property of integral to it right so I see addition and subtraction sign in between so integral sign can distribute inside for each term so what I get is integral x squared dx the first term plus well 4 is a constant so it can come out of the integral sign so I have the integral of x dx and minus so 5 is a constant but we have the property of the integral of constant right so I don't need to bring it out okay so for this guy okay my guess solution must be x cubed okay the degree greater than this by 1 but when I take derivative of x cubed 3 is coming up front and I have x squared see 3 is the extra number so I have to adjust my guess solution by divide 3 so after I take derivative so 3 can cancel 3 okay so the integral of x my guess solution is x squared but when I take derivative I have 2 extra right so I have to divide by 2 at my guess solution okay and this one you have a property right the integral of constant 5 is equal to 5x okay because when you take derivative of this, derivative of x is 1. So you get 5. Okay? And after you find the solution, then you need to add c to it. Now, let me put it in the big screen. Example 2, which is the integral of 4x squared minus 3x plus 1 over square root of x dx. Okay. Well, we have similar function like this when we talk about derivative. Okay. But this one we talk about integral, right? But derivative and integral are opposite. So they are related to each other in the opposite way. Okay. But when you deal with the function, you do it the same way. Okay, what do I mean? What I mean is, well, you can see that you can change this into x to the power 1/2. You try to change anything in terms of power if you can. Okay, and you can see that if I divide x to the power 1/2 to each term, okay, so what I have is 4 times x. You have x squared divided by x to the 1/2. So when you have division and you have the same base, you subtract the power. Okay, so you have 2 minus 1/2, and 2 is 4 over 2. So 4 over 2 minus 1/2, you have 3 over 2. Okay, and similarly to the second term, you have x divided by x to the 1/2. So you have x to the power 1 minus 1/2, which is 1/2. Okay. And 1 divided by x to the 1/2, you can think it like this, which is you want to put x to the 1/2 up top. So you have positive power. So it should change to be negative power. X. Okay. So you can see that the reason why we do this, because every term will be in terms of power of x. So then you can find the integral. Okay. So it's equal to, well, the integral can come out for each term. For this term, 4 is a constant. So I do the integral, I integrate this term. Okay. So my guess solution should be x to the power of 3 over 2 plus 1. Okay. 1 is 2 over 2, right? So it's become 5 over 2. But when I check the solution by take derivative, I have 5 over 2 is the extra number. I don't have 5 over 2 here, right? So I don't want 5 over 2 to appear here. So I have to multiply by the reciprocal of this, which is 2 over 5. When 5 over 2 come down, they cancel out. Okay. And in the same way, negative 3 can come out of the integral. And my guess solution when I take integral of this is x to the power of 1 over 2 plus 1, which is 2 over 2. So I have to the power of 3 over 2, right? And again, when I check the solution by taking derivative, I have 3 over 2, which is the extra number here. So since I don't want 3 over 2 to appear here, I have to adjust my guess solution by multiply by the reciprocal of 3 over 2, which is 2 over 3. See, when 3 over 2 come down, so they cancel out. Okay. Now, same as this one, I do integration of x to the power of negative 1/2. So my guess solution should be x to the power of negative 1/2 plus 1. which is 1/2. Now, when I check the solution, take derivative, 1/2 come down, right? So I have 1/2 is the extra number. So I have to multiply by the reciprocal, which is 2/1, which is 2. Okay. So when the 1/2 come down, so they cancel out. And I have to add C when I finish everything. Okay. Actually, I can simplify, right? 4 times 2 is 8/5. X to the power 5/2. This one, 2 times 3 is 6. Oh, actually, they cancel out. So I have 2x to the power of 3/2 plus 2x to the power 1/2 plus C. Okay. Next. I'll let you do this as the example, as the homework, which is integral of x to the 2/3 x minus 2 squared dx. And as you can see, if we want to try to do the integration of this, okay, you can see that you might want to, expand or multiply out this term. Okay, is equal to x minus 2 times x minus 2. You multiply them out, okay, and you distribute x to the power 2/3 inside, okay, then you are going to have something look like this, which is every term will be in terms of power of x. Then you can do the same method here, okay. So this one I'll let you do as a homework. Right. Okay. Now we just study about indefinite integral, which is something look like this. Okay. And we think this guy as something that is opposite to derivative, almost opposite to derivative. Okay. Now, the next thing that we would like to talk about is definite integral. So what you will see is something look like this. The integral from a to b fx dx. You can see that you have the running number here. Okay. And actually this number here is for x. So the integral from x equal to a to x equal to b. That is the meaning, okay, of fx dx. Okay. And first, what we want to know is, what is this? Okay, what is the meaning of it first? Okay, so I would like to start by, I'm going to make the condition for f first, which is I'm going to let my fx always greater or equal than 0. And your fx is your y, right? Your function has the y value always greater than or equal to 0. So in another word is, you have a function, which is a graph, a curve like this, that is above the x-axis, right? Because your y always greater than 0. So y always above the x-axis. So your graph is, above the x-axis. Okay. And since you are consider start from x equal to a to x equal to b, let's say a is here, b is here. Okay. Now, you want to see what is this? What does this mean? Or what is it? Okay. Now, you can see that x is between a and b. And I'm going to start looking at x any place between a and b first. Okay. X is between a and b. Okay. You can see that if x is here, my fx, so fx is going to be, you put x into the function, you get fx, right? It's the same as you draw the vertical line and hit your graph. And the height of this, which is your y value, is going to be fx. Okay. Now, if you remember, I did talk about dx before. Okay. Dx is coming from dy by dx, right? You just consider this, which is, I show you that the dy by dx is the limit when delta x approach to 0 of delta y over delta x. Okay. Go back and look at this. What I'm trying to conclude is that when delta x approach to 0 means it's very, very small. Okay. When your derivative exceeds the value, it makes delta y become very small too. So it transforms into this notation, which is instead of delta, when it's very, very small, it's become d. Okay. So dx in this case is very, very small change of x. Okay. Small change of x is actually delta x. So very, very small delta x. Okay. So now I consider any x. I know that my fx is the height, okay, which is the y value at x to the function. Okay. And this guy is dx, and dx is a very small chain of x. So I'm going to put a small chain of x a little bit over here. Okay, and the side is dx. Okay, then I have this side and I have this side. Then I can form the rectangle. Okay, it is the rectangle. And you can see that the product of fx multiplied to dx is the area of this rectangle here. Okay, so that means for any x, this I multiply together, I got the rectangle under the function. Okay, now if you can see now that, let's say my x, for example, is here, which is x is a. Okay, fx is going to be this height. I put small side of dx to here. I can form the rectangle. Then I get the product of fx and dx to be the area of this rectangle. Okay, and let's say my x is here again. And then fx is going to be this height. I put the side of dx over here. I can form rectangle. And the area of this rectangle is the product of this. Okay. let me try to do one more, which is, let's say my x is here. Well, fx is going to be this height. I can have small side dx, put it in here, and then I can form rectangle, and then I can have the product of fx and dx to be the area of this rectangle. Okay. So for each x between a and b, fx dx is going to be the area of the rectangle. Okay. Now, when you see the integral sign, okay, mean if you open the dictionary, something like that, you will see that it's the summation. Summation ครับก็คือการเอามารวมกันเนาะ so that mean it's the summation of rectangle for each x start from x equal to a to x equal to b. See, I'm gonna start from x equal to a. I have rectangle. I move to a little bit. I will have another rectangle. Okay. You sum this to rectangle means you put them together, right? And then if you move x a little bit, you have another rectangle. Okay. And you sum this three rectangle. So you add the area together. Okay. And you keep going. You're going to have rectangle, 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 right? Put it next to each other. Okay. And you sum up the area of every rectangle together. The outcome is going to be the area under the graph between A and B, right? Okay. So you sum the rectangle for every x from A to B ก็คือเอาสี่เหลี่ยมเนี้ยมาเรียงต่อกันใช่ไหมรวมกันนะครับเอามาเรียงต่อกันสำหรับทุก x มันก็จะมีสี่เหลี่ยมชิดกันมากเลยนะครับ the result is going to be the area under the graph. Okay. Now, remember that the case we are consider is the case where your function is above the x-axis. That is, your function always greater or equal than 0. Okay. Now, when you find the area, your area will be positive. Okay. Now, you can see that when you have the case, when your fx is less than or equal to 0, which is you have, let's say the graph, y is less than 0, so y has to be in this area. So your graph will be under your x-axis. Okay, let's say your A is here, your B is here. Okay, that means the area that you will get is going to be this area here when you do integration, definite integration. Start from A to B of fx dx. Okay, it's going to be the opposite way of the above, right? And the outcome has to be negative. Okay, because it's the graph under the x-axis. Okay. Now, you can see that if you have a case of mixed situation, let's say you have A, you have B here, and your graph something look like this. Okay. The area above the x-axis here is gonna be positive. Okay. And start from this point, you have the graph under x-axis. So you will have this area to be negative. Okay. and again you come up above the x-axis, so this area will be positive. Okay, so when you find the integration from a to b, this area will add up to this area, and you have to subtract this area. มีการหักล้างกันเกิดขึ้นเนาะบวกกับลบนะครับในกรณีที่ผสมเนาะเข้าใจแล้วเนาะสรุปคือ integral from a to b นะครับ from a to b when your graph above the x-axis is going to be the area under the graph and the area is positive. When your function less than or equal to 0, your graph is under x-axis. The area that you get is going to be negative. When you have mixed situation, the area above the x-axis will be positive, and the interval that the area is below the x-axis, the outcome will be negative. And if you want to find the integration from the integral from a to b, นะครับ it will have some cancellation ก็บวกก็รวมกับบวกแล้วก็มาหักกับลบตรงนี้นะครับโอเคเนาะ now you know the meaning of definite integral. Let me give you an important property of definite integral. Okay.ตัวอย่างครับหาคุณสมบัติหรือโอเค two important property. First one, the definite integral from c to c of f(x) dx is 0. Okay, of course, you know that definite integral is the area, right? Now, let me give you the example by every example now. From now on, I'm going to give you the example when x above the x-axis. Okay, I'm not going to talk about when f below the x-axis or mixed situation. If it's true for this case, it's true for any other case. Okay, so in this case, you have a function like this, okay, above the x-axis. Now, you find the definite integral start from c to c. So you start from c, which is here, and you go to c. That means you don't move from c at all. You stay at the same place. What you get is a line, right? It's not the area, okay? It's a line. So a line is in one-dimensional space, but area is two-dimensional space. So you have a line. That means it has the area 0. Okay. เราไม่ได้ area มาเลยมีแต่เส้นใช่ไหมครับ area มันต้องเป็นผลผลิตของ2มิติเส้นมันคือ1มิติใช่ไหมครับแสดงว่าผลของการอินทิเกรตก็ต้องได้0เพราะเราไม่ได้พื้นที่มาเลยมีแต่เส้นไม่มีพื้นที่นะครับโอเค next is if you want to switch the running number here and you want to flip it into the opposite side, so start from B to A. what you get since you go in opposite direction, you need to get negative. Okay. Now, what I want to show you is more properties of definite integral, which is this here. Okay, this two we just talked about. And here is more properties, which is when you have definite integral of constant time function, again, constant can come out, okay, of the definite integral. Okay. And when you have two functions add or subtract to each other, the integral can comes in for each term. Okay. Now, this is an important property, which is when you integrate from A to B, okay, it's equal to integrate from A to C plus integrate from C to B. So let me prove by picture, which is, let's say you integrate from A to B. And you know that the meaning of definite integral is area under the graph, right? From A to B. Okay. But on the right-hand side, you can see that first I start from integrate from A to C. Let's say your C is here. Let me use the red color. Okay, from A to C. And it's definite integral. So it should be the area under the graph from A to C. So what you get is here. Okay. And you add definite integral from C to B of fx dx. So you get the area from C to B under the graph, which is this area. And you can see that the two red areas can sum up to be equal to the blue area, which is on the left-hand side. Okay. In another word is, instead of finding the area from A to B straight, โดยตรงนะครับ you just separate this area into from A to C plus from C to B นะครับก็คือการแยกพื้นที่ออกเป็นสองส่วนนั่นเองเนาะแล้วก็รวมนะครับอันนี้มีประโยชน์มากนะครับ and number 4 it's the fact that we know, right? When f is above the x-axis, which is greater or equal to 0, some place it can be 0 or it can be on the x-axis. Okay. And the integral from A to B always greater or equal to 0. ครับก็จริงเนาะพื้นที่ของกราฟที่อยู่เหนือแกน x อาจจะมีบางส่วนที่มีอยู่บนแกน x บ้างอะไรอย่างเงี้ยครับพื้นที่ก็จะเป็นบวกหรือ0ถ้ากราฟของเราเป็นสมมุติว่าอย่างเช่นเป็นเส้นบนแกน x ทั้งหมดเลยทำไมครับพื้นที่มันคือ0เนาะเนี่ยนะครับก็มีสิทธิ์เป็น0ได้เนาะคราวนี้ number 5 if f less than or equal to g นะครับ for x between a and b then the integral of f definite integral of f less than the definite integral of g and this fact is you know that g greater or equal to f, okay, so that means g is higher than f, okay. Now that means the integral from a to b of g since it's higher that means it has more area. Okay, this one is below, right? Fx is below, so the area under F has to be less ครับก็ได้พื้นที่น้อยกว่าเนาะbut they can be equal because if they are equal, okay, so the integral should be the same. Okay, number 6 is the result from number 5. When you have g strictly greater than fx, no equal. Okay, that means the area that you get since it's higher has to be strictly greater than the area under fx. Okay, last one. When you have the absolute of definite integral, it always less than or equal to the integral of the absolute inside. Okay, now let me give you an example. Let me my fx has the graph like this. Let's say from -1 to 1, and let's say the line is this line make 45 degrees from x-axis. Okay, and you can see that once I have this graph, and let me give you that this is my fx. Okay, you can see that the integral, let's say from -1 to 1 of my f, so it's going to be the area from -1 to 1, but this one is below the x-axis. The area of this is negative, but from here to here the area is above the x-axis, so the area is positive. And the graph that I draw to you, it's symmetric, right? So the area of these two are the same, so they cancel out to be 0. So the absolute value of 0 is 0. Okay, but if you put absolute inside, or you put absolute for fx, so that means for your fx that positive already is going to be the same when you put absolute for fx. Okay, but for any place that fx is negative, when you put absolute in, it's gonna turn out to be positive. So this part here is gonna, go up top, right? กับเด้งขึ้นไปข้างบนเพื่อให้เป็นบวกใช่ไหมครับอะไรที่เป็นลบเด้งไปบวกลบตรงนี้ก็เด้งไปเป็นบวกเท่านั้นหลังจากใส่ค่าสมบูรณ์นะครับ so that mean now this part is the same, so this red graph here is a graph of y equal to the absolute of fx. Okay, so when I do the definite integral form, in this case -1 to 1, you can see that instead of having negative area, I have positive area now. Okay, and this side I have positive area, so I integrate from this to this, so I sum up the two area together. ก็คือการใส่ค่าสมมุติเข้าไปมันทำให้ฟังก์ชันเนี่ยเด้งอยู่เหนือแกน x หมดเลยทุกที่มันก็ไม่มีการหักล้างกันเหมือนซ้ายมือใช่ไหมครับแล้วค่อยมาใส่ค่าสมบูรณ์ที่หลังเพราะฉะนั้นค่าทางขวามือจะมากกว่าเสมอเพราะทุกอย่างมันเด้งขึ้นไปอยู่ข้างบนหมดนะครับแล้วก็การหาพื้นที่มันก็เลยเป็นเอามาบวกมารวมกันหมดเลยก็จะต้องมากกว่าซ้ายมือเสมอนะครับOkay, these are important properties for definite integral. เนาะนี่เลยเวลามาแล้วขอไปตรงนี้นะครับส่วนนิดนึง now คิดว่าไม่น่าจะจบนะวันนี้เอาให้จบไอ้ตรงนี้ก่อนเนาะแล้วก็เดี๋ยวไปขอเวลาเพิ่มนะครับ แล้วก็เอ่อติวให้เราด้วยนะครับ ขอเวลาจบเนื้อหาแล้วก็ติวให้เรานะครับโอเค next เอ่อ to okay, to theorem for definite integral นะครับ เราจะเรียกว่าthe fundamental theorem of calculus นะครับ mental theorem of calculus which is the first one นะครับ it said that when you have derivative with respect to x of integral definite integral from a constant to x ft dt it's equal to f of x นะครับ okay so in this case you can see that you don't have to do the integral first and then you take derivative okay this theorem said that when you have integral from c constant to x of function f depends on t dt when you take derivative with respect to x you get this function and you get variable x here okay now let me give you the idea which is you can see that you have function f you do integration and when you do integration you do derivative these two things are opposite they cancel the effect so you get f back okay now your question is what should be a variable that this function depends on okay so if I consider this if you remember now I have f depends on t right instead of x okay let's say this is my f of t and you can see that I start from c to x see this one gives you the area right now you can see that if my x is over here I get this area here if I move x to this one you can see that I gain more area right I get this area okay so that means this gives you the area but the area here depends on your x here because this one is fixed depends on x so that means just only this circle thing here depends on x ใช่ไหมครับเพราะมันให้ผลลัพธ์คือพื้นที่อ่ะแต่พื้นที่มันขึ้นอยู่กับว่า x อยู่ตรงไหนถ้าไปมากมันก็ให้พื้นที่มากถ้าไปน้อยมันก็ให้พื้นที่น้อยถูกไหมเพราะฉะนั้นพื้นที่ตรงนี้ depends on x มันก็คือฟังก์ชันที่ขึ้นกับ x นั่นเองก็ให้นึกถึงว่าไอ้วงกลมตัวเนี้ยเป็นฟังก์ชันที่มีแต่ตัวแปร x เห็นนะครับเพราะฉะนั้น when you derivative with respect to x you have everything in terms of x here when you take derivative with respect to x you should get in terms of variable x that's why the result is a function is in terms of variable x นะครับโอเควิธีจำก็คือยังไงเริ่มจากฟังก์ชันอินทิเกรตและทำสิ่งที่ตรงข้ามคือ diff ก็ได้ฟังก์ชันกลับคืนมาถามว่าผลลัพธ์ตัวแปรคืออะไร you just take this plug it in here you get x okay let me give you an example which is find d by dx of integral from 0 to x dt over 3t squared plus 5. Okay. First, this one is a constant. Okay. Okay. Now, let me change this term here so that I can see what my f is. So this one equal to d by dx integral from 0 to x. Well, I'm going to move dt outside. So I left with 1 over 3t squared plus 5. And this is my ft. Now, this is already constant, and I can determine ft. Okay, so the result from the fundamental theorem of calculus, okay, f integrate and then you do derivative, you get f, and you just take x into you just replace x for t here, so you get f of x as a result. Okay, but since your f is equal to this in terms of t, right? You want fx, so you just replace t by x. So what you get is 1 over 3x squared plus 5. That's it. That is your solution นะครับอย่าลืมนะจะไม่มี plus c นะครับเพราะ theorem ไม่มีเนาะโอเคเนี่ยไม่ต้องอินทิเกรตก่อนแล้วไปดิฟนะครับเนี่ยก็ได้ผลลัพธ์เลยโดยใช้ทฤษฎีนะครับnext it is the result from the first theorem, which is when you have d by dx of integral of from c, now not 2x but a function of x, ft dt. In this case, again, you have f back, f integral derivative, you get f back, but do the same thing, which is plug this into here, which is u of x. But you have to do more since this is not x, right? If you have x here, you just plug it in and then you are done. But this one is a function of x. After you plug it in, you have to multiply by du by dx. The reason is, okay, well, you can see that this guy now depends on ux. So the whole thing depends on ux. And u is a function of x. If I want to take derivative with respect to x, I have to use the chain rule. Okay, so that means first I have to take derivative of this guy with respect to ux เนี่ยนะครับ ux แล้วก็ดิฟเทียบกับ ux ก่อน แต่ทำไมครับ พอตรงนี้เป็นดิฟตรงนี้เป็น x เทียบกับ x ก็คือเอาตัวนี้ใส่มาที่นี่เลยแทนที่ t ตรงนี้ถูกไหมเพราะฉะนั้นถ้าผมมี ux แล้วก็ดิฟเทียบกับ x ก็เอาตัวนี้ใส่เข้ามาที่นี่ก็คือได้ส่วนนี้นะครับเนี่ยเป็นส่วนลูกโซ่ตัวแรกเสร็จแล้วมันเป็นลูกโซ่ก็ต้องเอา u มาดิฟเทียบกับ x นะครับ you take derivative of u with respect to x นะครับ that is the formula. Okay, so let me give you an example, which is find the derivative with respect to x of definite integral from 0 to 2x squared plus 3 of dt over t plus 1. Okay, this is a constant. Ready? This is your ux. Okay. Now let me change this guy. So let me pull out dt outside. So I have 1 over t plus 1. And this is my ft. Okay. And this is my ux, right? And by the fundamental theorem of calculus, when you have this, well, you have f, plug this into t. This is your ux, right? And multiply by du by dx. Okay. So that means this is my ft. I plug this into t, so I have to plug it in here too. So I have 1 over 2x squared plus 3. This is your t. And then plus 1. Okay. And this one, I have to take derivative of my u, which is this one, 2x squared plus 3 with respect to x. So the result is 2x squared plus 4 times derivative of this. Take this is 4, and then x, and then derivative of this is 0. Okay, so that is your solution. ครับโอเคเนี่ยก็จะประมาณนี้นะครับตอนนี้คิดว่าที่ผมจะพูดต่อไปนี้ไม่น่าจะออกนะ ก็คืออ้าวแล้วเราเกิดถามว่าอ้าวถ้ามันข้างล่างมันไม่ใช่ค่าคงที่ล่ะอย่างเงี้ยฟังก์ชันอะไรก็ได้นะครับตรงนี้เนาะอะไรก็ได้ แต่ถ้ามันเป็นอย่างนี้ทำไง ถ้าเราจำได้ definite integral มีคุณสมบัติพิเศษนะครับ ผมก็อาจจะอย่างนี้ก็ได้ แทนที่จะอินดิเกตจากนี่ไปนี่โดยตรง เพราะถ้าผมจะใช้ fundamental theorem of algebra เนี่ยมันจะต้องมีค่าคงที่อยู่ข้างล่างถูกไหมเพราะฉะนั้นผมก็อาจจะทำอย่างนี้ก็ให้ค่าคงที่มันเกิดก่อน แทนที่จะอินดิเกตจากนี่ไปถึงนี่โดยตรง ผมก็อาจจะอินดิเกตจากนี่มาถึง0ก่อนก็ได้ เลือกตัวเลขมานะครับก็จะได้ x squared plus 1 to 0 of ft dt and then you add it from 0 to this แบ่งพื้นที่ออกเป็น2ส่วนใช่ไหมครับแต่ประโยชน์ตรงนี้คือ so you have constant exist now นะครับอ้าวตรงนี้ก็ทำไมครับผมอยากจะใช้ทฤษฎีก็ต้องเอา0เนี่ยลงมาข้างล่างไอ้ตัวนี้ก็ต้องไปอยู่ข้างบนก็สลับตำแหน่งใช่ไหมแต่เราก็มีคุณสมบัติรองรับอยู่นั่นก็คือถ้าเราจะสลับตัวเลขตรงนี้ต้องได้เครื่องหมายลบมาเนาะ and then add to 0 to x cubed plus 7 ft dt ครับ so if you want to take derivative of this is equal to take derivative of this but derivative can distribute inside for each oneตรงนี้ผมก็ใช้ fundamental theorem of calculus ได้ละข้างล่างเป็น0เป็นค่าคงที่ข้างบนเป็น ux เห็นไหมครับก็ใช้แต่ละเทอมได้เพราะฉะนั้นอันนี้คือการประยุกต์เผื่อเราเจอในอนาคตที่ไม่มีค่าคงที่เราก็ทำให้เกิดได้นี่ก็แบ่งพื้นที่ก็จากตรงนี้แทนที่จะอินดิเคตไปถึงนี่ก็อินดิเคตจากนี่ถึง0หรืออาจจะเลข1อะไรก็ได้นะครับแล้วก็จาก1ถึงตัวนี้นั่นเองเนาะ โอเค คิดว่าวันนี้อาจจะเท่านี้นะครับ ก็จะเหลืออีก2เรื่อง ก็คือว่านะครับ next we will answer how to find จะหาค่ามันยังไงนะครับ ตัวนี้เนาะแล้วก็ we will go back to indefinite integral แล้วก็ที่เราเรียนมาเนาะก็คือใช้วิธีการว่ามันน่าจะเป็นคำตอบอะไรนะ แล้วก็ทำการดัดแปลงคำตอบนะครับ แต่คราวหน้าก็จะมี more เทคนิคนะครับ เทคนิคนะครับ to help you find the indefinite integral ครับตรงนี้โอเคผมอาจจะพูดเทคนิคนี้ก่อนก็ได้นะครับ แล้วก็ค่อยพูดถึงตัวนี้เพราะรู้ตัวนี้ก็จะช่วยตัวนี้นะครับเนี่ยเพราะ2ตัวนี้มันเขียนคล้ายกันเนาะมันก็ต้องน่าจะเกี่ยวข้องกันนะครับเดี๋ยวค่อยว่ากันคราวหน้านะครับ มีคำถามไหมเอ่ยอุ๊ยถ้าไม่มีก็เท่านี้ก่อนนะครับ แล้วก็เริ่มทบทวนเนาะแล้วก็อ่าพยายามเนี่ยเนื้อหาตรงนี้ก็ดูตามแล้วก็เดี๋ยวคราวหน้าก็จะมาตอบนะครับคิดว่าจบแล้วก็จะติวสอบให้นะครับผมโอเคครับสวัสดีครับ